Let him introduce first. Tiago, if you can stand there.
Yeah.
Yeah, notebook. The notebook. Code.
So let's start. So good morning, everybody. Somebody is checking.
Let me keep the stock spatial. Can also introduce website and everything.
Can.
Slide to planetary computer.
Okay.
Okay. Let's start. Okay. Yeah. Good morning, everyone. Myself Tiago. I am currently the host organization. I am coming from Satyukt Analytics. So we are happy to host everybody for this event of the November's event of the Let's Talk Spatial. So just the basic things. If anybody wants restrooms, it is on. I'll leave it. It's nothing important. It's on the right side. And if you have if you want water or something, you can get it on that corner. Okay. If you want the Wi-Fi is the guest account will be there. Satyukt's guest account Wi-Fi you can use. The password is user123$. So what we will be doing today is it's more like a hands-on. So people who wants to sit close by, you can come forward and sit close by. Okay. So you can see the monitor properly and so there will be two hands-on. One is first will be given by Santosh. Santosh will be giving about the introduction to the planetary computer. Based on the time he may dive deep into what he was going to do. And then again next is by Aman. Aman will give it about the STAC APIs. And at the end we will have information about we are going to host the Ingress 2023 Bangalore will be happening in December. So Amrut will be giving us about what is that event is and what you will be getting. So if you are interested, you can register for that event. And Let's Talk Spatial also organizing some challenges as part of the Ingress event and with a very good prize money. I think up to $1,000 of the prize money is up for grabs. So you can have it. So now I will call Santosh. So how the session we generally goes, if there is somebody who is new for Let's Talk Spatial, we will have one talk. After that, there are two types of sessions we have. Today's session is more like a hands-on or workshop type sessions. Other session is where we will have the talks from the 3 or 2 speakers will be having. So after the first session on the hands-on, there will be introduction or everybody will introduce about what we are doing, like networking kind of thing. And then the second session is about, again Aman will be giving. After the Amruts, then at the end of the session we'll be having networking and it will be open for networking. You can talk with anybody, whatever you want to interact with the people, you want to ask about any advices, anything, any doubts, anything you can ask, and you can stay as long as you want. Okay, the office will be open till everybody leaves. Okay, we won't close soon or anything. So that's it. So now,
Website is
okay. So we have this is the website we are showing. Let's talk spatial.in. This website is there. There you can see the recent events which was happened and what is the topics of the event. And if you want to know about what will be the new events coming up, we keep on posting in our Slack forum, or you can see it in the Meetup page. So where we generally is the first place where we put everything is maybe the Slack, and then the Meetup page is the where the new meetups or something will be posted. That's it. So now we will have Santosh. So he is the open source contributor for last 3 years, more than that, and he will be today giving us the introduction to the planetary computer. If somebody who don't have maybe he will tell it, but if you don't have the account, you can use the collab to practice whatever he is going to do. Okay, let's welcome Santosh.
Hello. Thank you. Okay. Yeah, I'm also an co-organizer of Let's Talk Spatial, so I take the liberty to welcome you all to this event. So today I'm going to explain about the planetary computer, how it can be used, what is planetary computer basically. So can I just have a show of hands? Has anyone used planetary computer before in their work? Anyone else? Okay. Have anyone used cloud computing for geospatial analysis? Okay. What cloud computing have you used previously? Google Earth Engine. Great. Anyone else? Google Earth Engine, everybody. Okay, great. So I have designed this little hands-on session in a way that since we all have Google Earth Engine experience, so how Planetary Computer is different from Google Earth Engine. Why we really need to know Google Planetary Computer, since we already have a product called Google Earth Engine. What Microsoft is trying to address. So I thought I can address that because in online there are like many videos that are introducing Planetary Computer as an geospatial tool, cloud tool where you can get data. So all those things you can just go and see. But this comparison from a perspective of an Earth Engine user. So even I am a heavy Earth Engine user. So I have been using Earth Engine for like past 3 years. So I love Earth Engine a lot. But from my perspective, how a Planetary Computer is excelling in this field, or like where Planetary Computer can improve, where Earth Engine is still doing the best. So I thought I can do a comparison and make you guys aware of it also. Great. This presentation link will be shared in the Slack group, so you can get it from there. Okay, so Planetary Computer, there are many definitions given to it. Even you can see in the website they have like written a big definition, but basically it is a tool where we can do geoprocessing in the cloud. So that's all we need to know. But now let's address why we need to use the Planetary Computer when we have Google Earth Engine. The first thing, the first thing is it's open and like decentralized. When you do in Earth Engine, it's not open. Whatever we do, we are like sending some codes. We are using the API. We are asking like .ndvi or like something like normalized difference. Obviously, we know what normal difference is going to do, but we don't know what it is doing in the backend. So that is like not openly given by the Google. So it's kind of closed. So Planetary Computer is open. And it is decentralized. Even Google is decentralized. Like we can have the data anywhere we want, and we can work. So that is one advantage of Planetary Computer. And the next is data ownership. When we talk about data ownership, although Google Earth Engine is giving you 250 GB of storage where you can upload your data, but you don't have a policy for the data. Like whether we can have the data, it's obviously it is going to be private to the user, but still there is no concrete policy. But Planetary Computer has a defined thing where we are going to use the storage as in the Azure blob. Azure blob is in storage, like it is already well defined. So it is having a clear path, like this is how we are going to travel. We are going to create a data catalog, and data ownership and other privacy licensing things is already through our Azure platform. And the next is the customization and flexibility. One key feature Google Earth Engine lacks is the customization. So what Google has to offer, we can use it, but we can't customize it. So that is a serious problem in Earth Engine, but the community and the company is addressing that issue in a rapid manner. But still, this was a key issue, and Microsoft took that and they are like building their product on it. So here you can like customize it. Since it is built on Python, using Python, you can like customize it as per your requirements. And the final is scalability. So while using Earth Engine, the scalability is limited to their compute. You can't like say I want GPU. You can't like say I want like this much amount of computer. You can just give the query in the backend. Whatever scalability Google offers, that is the scalability you get. But here you have all these scalabilities and other things which you can do. But still, Planetary Computer is in a nascent stage. Like it is still being developed. Comparatively, Google Earth Engine is much more developed. So these are the 4 points. I thought like Google Earth Engine versus Planetary Computer, we can like differentiate. Okay, now let's compare this chart. So in this I have just drawn 5 things. One is the data catalog, next is processing power, next is the programming language, and hardware control, what we can get, and cost. So this isn't very simple, so I just wanted to put it as a chart because we will get on the same page. So as a data catalog, if we see Earth Engine has a vast amount of data. So even Sentinel and Lance are very common, like even it is available in Planetary Computer, but still there are many other data which are available in Google Earth Engine. It's not available in Planetary Computer. as a heavy user of Earth Engine, you would have some GE catalog which is maintained by the non-Google folks. So there are like lots and lots of data that are being pushed into this. But the Planetary computer don't have any community data like that. So only the data that Microsoft they have in their blob storage is available for users. There Google Earth Engine shines well. And the processing power, as we discussed previously, scalable. So Earth Engine can't be scaled. Now that is being addressed, but still Planetary computers shine in that area. And programming language, here it is built on JavaScript API. So if you have used code editor, it is JavaScript. It's not Python. So you need to learn something new, which is like not used in the regular analytics world. Someone who is doing this job will be a data scientist or an analyst. Those who don't know JavaScript, they need to learn JavaScript, especially for Google Earth Engine. But if it is in the other Planetary computer, it is using Python, Jupyter Notebook. So it's completely relevant to analytical domain. And hardware control, Google Earth Engine is nil. You can't have control over the hardware. Here you will have control over whether you can have a CPU or a GPU. I will also show you through Planetary Hub how you can select the GPU and CPU for yours. And talking about the cost, so Earth Engine started as it's going to be free. Then they said that it's going to be free for only academic and non-commercial users. So that's the stand they have taken now. But in Planetary computer, they clearly said it. We have a free trial, and then you will have to pay for Azure. So like companies can have a clear path. Okay, this is the cost we might be inquiring when we are using a Planetary computer. So this is the comparison of Earth Engine versus Planetary computer. Okay. Now let's specifically talk about the programming aspect in both these things. The first is Google Earth Engine is in server-side computing. What is server-side computing? The computation, right? For example, if your computer is having in 40 GB of RAM, it's not going to be used. Everything is in the server of the data center. So you're going to write some APIs and send it to the particular center, and then the computation will be done at the center, and the result will be streamed back to you. So this is how Google Earth Engine is defined. Even the Planetary computer works in that manner. The Planetary hub is not in our local system. You can get an RAM and then a ROM for you assigned, but it is not like you will send a code and the code will be processed at their server data center. You don't know what's happening. You can have a client-side programming. So if you are new to server-side programming, it might be difficult for you to understand Google Earth Engine, but the Planetary computer is making a better decision of having a client-side programming. Yeah, this is again it's programmer friendly because it's in the Python thing. So Planetary computer has a Python base. Google Earth Engine is also like developing their EE package. If you guys are following it, recently they did XEE. So they are trying to integrate the EE package with the X-arrays. So they are like improving on it, but Planetary computer is built on it. So Planetary computer has a clear advantage of this programmer friendly. And talking about the debugs, so Earth Engine won't give you a clear debug error. It will just give you feature 0000123. You don't know what is happening. I have like after like seeing that type of error multiple times, you can come to a conclusion. Okay, this might be the error, and I am getting this. For example, you have a raster image and you are trying to sample it. Your one point will be like outside the raster. You want to get a type error or data error. There will be like a feature 000 missing. You will be like, I have all the features. Why it is giving such error? So once you start debugging it, like when you get familiar with, you will be like understanding these errors and solving it. Even if you copy paste that error and go like Google, you won't get a Stack Overflow to resolve it. So here Google Earth Engine is not really great at giving these errors and debugging. Planetary computer can give because it is using the Python interface. Next is use of the LLM. So now Chat, GPT and Bard, like they are the go-to tool for everyone to get their code done. So here I will also do a comparison in the next slide where the Chat GPT and LLMs are performing, how they are performing for Google Earth Engine code and the Planetary computer. Okay, so yeah, now let's do real world use cases. Now here first I thought let's do an NDVI code actually. in both Google Earth Engine and in Planetary Computer, and then compare it. Then I thought, okay, if you want to do an NDVI, if I am tasking some newbie, hey, can you just download a Sentinel data and then do an NDVI, do this date filter, do this cloud filter? Their first thought will be, okay, I will just ask ChatGPT to do this for me, and then I will just go and correct the code for my location. So what we are going to do is, so we are going to build a script. This is the question I am going to ask in the ChatGPT and in the bar. So let's see how it responds. Okay. The first is I am going to ask build a script to use Google Earth Engine JavaScript API to compute NDVI for Bengaluru using Sentinel-2. And the filters I am going to use is use it for 2020 and then create a composite, and also create just a 20% select images which have 20% of cloud cover. So I am just going to copy this. Use? I can, but still, it's okay. Everyone don't have access. Hey, everyone don't have access to GPT-4. Okay. Any cases how this will be, whether the ChatGPT will be able to build this or not? Huh? It may give some or no, it will build the code or not. I am asking like build a script. It will build. Okay, let's see. Okay, let's go through this code. So it is like selecting an coordinate. It is just creating its ROI, start date, end date. That's fine. 2022. Here one error is it should be like +1 date. It should be 2023 1st of Jan because end date is not included. And then it's doing cloud masking, and then it's taking the Sentinel S2. It doesn't select the SR product. It just selected the S2. It is like filtering to the ROI, start date, end date. Mostly it is correct. So here it did really well. Now let's ask the bar whether it can. Okay. Bar is saying import EE. I don't know, it is importing EE. It's in Python library and using var, which is in JavaScript. So it is kind of little bit confused. So this won't work. Like it is mixing the Python and JavaScript. Now let's ask the our assistants to do the same for Planetary Computer API. Like if in case I want to run this in Planetary Hub, whether it will able to. Oops. Okay, will this be built or not? Any guesses? It will give an output. No.
It may not able to.
It may not. Why?
Maybe it's very latest.
Okay, correct. So this is a little bit latest technology. So this ChatGPT is like not updated to it. Maybe ChatGPT 4, if you subscribe, you can get code. But it will eventually say like, hey, I can't do this. This is like up to the knowledge of 2022. It's like not good. So the code which is given here, it's like giving something else, but it's like not what we want. And also it's like as of my last knowledge 2022, it's like not good. So Earth Engine is like much old. Your LLMs can help in like debugging your script, but again, when coming to debugging, it's not just about the LLMs. You can like go and get your help in STAC Exchange. There you won't get help for Earth Engine much. You can get help for Python. Okay, now let's ask the bar to do this. It's again giving some output. but again this is not correct. So clearly this is also like not correct. So when I was building this particular session, I did notice one thing. As you know, Google Earth Engine is built by Google and Planetary Computer is built by Microsoft. BART is built by Google and ChatGPT is backed up by Microsoft. So what I noticed is when I asked about Planetary Computer versus Google Earth Engine with BART, BART was like, hey, Google Earth Engine is the best, Planetary Computer is okay. Like that, even the disadvantages of Google Earth Engine, it was like little bit partial to Planetary Computer in my opinion. Like it was, although this assistant is not a really assistant, it is an advocate for their company's product to us. So we should be mindful when it gives some results. We should also consider, okay, this is BART, it might be like promoting the Google's product. So this is what I observed when they using this assistance. So I just wanted to let you guys also know. Okay, great. Now let's actually go into the Planetary Computer and then see how we can log in and how we can register. Okay, so this is relatively new. Like for the last 2 years, this development is being done. So you need to first register and your account needs to be approved. Still this is the preview stage, this is not fully mature. Everyday development is being done, so you can like see lot of new features are being added in the due course. So if you are new, come to this website, request access. Here is just a form. If you just fill it in like 24 hours or so, like your account will be approved. So once approved, you can come to this hub. So it's one of the way to use Planetary Computer's data catalog, but Aman will say about the STAC and other things where you can also use it in the local. But if you want to use the hub, you should request the access, and then once you click hub, you can come here. Oops. Okay, once we since it's already logged in, it just came into the notebook page. But when you click on the hub, it will ask for whether do you want to open an CPU environment, or whether you want to open an R environment, or you want an GPU. Whether there a page will come. Maybe I can show an image for that. Okay, so yeah, when you first time log in, when you click the hub, this will be the interface, and when you choose sign in, you will be having these options. Whether you want to open an CPU, and you can see it is an Pangeo notebook environment. So what is Pangeo notebook environment? It is basically Pangeo products that are hosted in the clouds. So what are Pangeo products? Like the X-rays or the climate data. So you can read a lot about Pangeo data. Basically it has the X-rays and DASK which are pre-installed for our use case. And also it has the GPU and PyTorch, and they have kindly mentioned it has a longer time startup. But in my experience, this is like this doesn't even start up. Like it will take a long time and it will fail. And QGIS is still under preview. I have used QGIS, but it is like very in the nascent stage. They are having a roadmap to build it, but there is a lot of way to improve. So for now, the CPU Python is the mostly everyone using. So when you click CPU Python, you will have this interface. Here you will have sessions for tutorial, and they have put some scripts. You can use this script to build your own. You can, if you want to create an NDVI, just come here. There's a script for NDVI hotspot. You can understand now after Aman explaining about this STAC, you will have a better understanding about how to get the data, how the data is being ingested. So once you understand those things and all, you will have a better picture on how to work with STAC. But there are like a lot of tutorials available here, and also in this Planetary Computer page you have applications, and in the applications you have like many applications. You have the code also available with it, so you can explore these things. And I want to show this data catalog page. This is very easy to use. As a geospatial scientist, you will be like easily understanding this, what is MODIS, what is Sentinel-1. So I'm not going to go in depth on this. But there are like many products. There are also tags. So you can like, if you want to do fire, you can like come and click on fire. It will list all the products that are like related to fire. Okay. So now let's go back here. This is basically a Jupyter notebook that is hosted on Azure, and it is having special permissions for Planetary computer, where it can basically that special permission is it has the signed in key. If you don't use this Planetary hub, you should like do pc.signin, put your API and their password to sign in. But this is in this hub you will be like signed in already. That is one thing. And now I'm going to do one hands-on. So this is the only hands-on I have. I thought I can show you guys what the hands-on is. So everyone would have seen the ESA land cover. So the ESA land cover is having like 13 classes all over the globe. ESA did the classification of LULC using 13,000 points available across the globe. So they did train and they did release 2 land covers, one for 2020 and one for 2021. So that both the products are available in Planetary computer. So what we are going to do is we are going to fetch the data, and also I have this Delhi geo package. How QG sir? You don't have QGs?
No, I have QGS.
Oh, you installed it in Python.
Yeah.
Okay. Great. Okay, cool. So this is the shape file for Delhi, geo package for Delhi, vector bounds for Delhi. So it is, as you can see, like it is having 29 districts inside it, or like we can say counties, something. So we want to find for each of this district what is the land, like how much amount of area for like urban, how much amount of area for each class of ESA's land cover. So if you are having one like a geo package, then you can just do zonal stats on it, and you can find the total area of each classes. But if you are having an multi-polygon, then what will you do? Like how can we do this in Planetary computer? So that's the task which we are going to do. I hope the task is clear for everyone. And the inspiration to create this notebook for me is my mentor Ujjwal Gandhi. Last year he released a video on like how to do one categorical zonal stats in Google Earth Engine. Then I was like, okay, if this can be done in Google Earth Engine, why we can't do it in a Planetary computer? So then I went and then built this script. So it worked actually. Sorry? It's not like zooming, I don't know. Is it okay? Okay. Great. Regarding the PyStack client and the stack, the next section Aman will explain more about it. He will explain how the data are ingested, how it is stored, and how it's like retrieved, what is the nuances behind it. So I'm not going to go in depth on this. And then these are the like normal pandas geodata frames library, and this is the raster operation library. And I just imported few libraries for visualization also. So I'm just going to import this, and then I'm going to do this in projection transformation. For that I just created a function, and then here we have the Delhi geo package. I just show what is the Delhi geo package consists of. So I'm going to read it using the geopandas. Okay, and yeah, let's check the projection. It is 4326. Everything is done. So I'm just going to get the min max bounds Why we need this min max bound is to retrieve the data from the data catalog. We just need to pass the b bounds. B bound is the bounding box, so we can get the bounding box from using this. So once this is retrieved, I am going to use call the data catalog. I showed you the catalog over here. So to retrieve that, you can use this client.open and pass this API key, which will retrieve the data catalog. And then once you have this, you can search for this ESA world cover and pass this b bounds. This all are cloud optimized geotips. So once you pass this particular bounding box, it will retrieve the data for that particular bounding box, not greater than that. So let's see what it has written. 2 items. Can anyone say what are these 2 items can be? We just as you know, ESA LAN cover is a single product, and Delhi is so small. What would be this 2 product? It might have. Probably is dynamic world. That is different. Okay, let's print. Actually, it is the. Oops. It is a 2020 and 2021 LAN cover. So we are getting 2 products. I'm going to get the 2021 product and oops. Okay, so this is the particular reference key which is referring to the Azure blob storage where this particular data is stored. As you can see here, N27 is 075. That is a particular tile we are going to retrieve. So this is the LAN cover image which you are going to retrieve, and it is stored to this particular blob. Now what I am going to do is pc.sign. So I am going to sign this key, make it aware that on this particular IP address this data is being retrieved. So if I do this, so basically it is the same link, but it is having this particular address. So Azure or the Microsoft can know at which IP address this data is being pulled. If data is being pulled more, they can stop it. So no news on it, but they can have control on this. So in my opinion, they won't give their blob storage for free. So this is the point where they can monetize it. You can download this much amount of data only, or you cannot download a bulk data. So this all can happen in future.
Now you are running the code, right? So for us to practice, you will be again sharing the code, or how?
Yeah, I will give the code and the geo package. Now itself, we can try.
So once you've done it, then again you have time to practice.
Yeah, maybe the same code we can do.
So we can just do the practice. You can share the code now. So we can practice around.
Okay.
Here you can recommend it.
Okay.
Another plan you can do as per your asking.
Anything is fine for me. So everyone is having access to Slack. Should I want to put this notebook on Slack, or where can I put this? Slack. Okay. No, how can I share it with them? That's the Slack. Slack is fine.
Or you can use tiny URL or something and then reduce the size of the URL. We can
That's okay.
I told you.
send it to me in that also. I can send it to you. If you send it to the office then, no? In the same stack.
No, I'll share. Also share it.
Share on my GitHub. I already have it in my GitHub.
No, you don't have this thing. No?
I have.
Okay, share it.
I have.
Just share the link.
Do you follow me?
You just tell people to go to this page.
Yeah. So this code is available in my GitHub under Python projects, categorical zonal stats. But also I will leave the link in the Slack group, so you can get access to it. Great. Okay, now let's continue. So we got the signed key. Now we are going to say, hey, this is the signed key, this is the product which we need to retrieve, and give me the product. So we're going to ask them, and then we are going to load the raster and visualize it. So here what I am doing is I am using the raster.io Windows option to pass the bounds. So since it's a cloud optimized GeoTIFF, we can just get the portion we want rather than this retrieving the whole tile. So today morning me and Aman had an instance where we forgot to give this bounds, and we are crunching in GB amount of data instead of crunching in MB amount of data. So these are a few things which can be done in Planetary computer or basically STAC. So now the data is being retrieved, and here I am just going to color it as per the ESA's world cover color standards. Great. Now we have the data and we have the vector file loaded. Now what I am going to do is do a categorical zonal stats for each district, and then find the statistics for each district. So yeah, I am just going to open this raster as an X-array data X data array, and then clip it over that particular bounds. Since it is having a rectangular bounds, I am just going to clip it to the particular Delhi bounds. If you want to have this as an output, this is also a lot of steps. To get this data, you need to go to ESA website, check your Delhi where it comes. You have to do a lot of steps and then download. But if you have the code for this, you can change the, if in case I want to do for Chennai, I just want to change Chennai.df package and run the code, I can get the data. So you can also write it as a raster file, export it as in GeoTIFF. So that can be done, but I'm not going to do it here. The next thing I'm going to do is check the reprojection. So what I'm trying to do here is ESA world cover is in the geographic coordinate system, and we are trying to compute an area. So area is in the metric coordinate system. So I'm reprojecting to one projected coordinate system, so we can get it in the metrics unit, basically square meters. So I'm reprojecting it. I'm using this 32643, which is the world Mercator. So anywhere in the globe you can use this safely. And yeah, next I'm getting that particular resolution. Once you reprojected it, it will be around 10 meters. Since we knew it is a 10-meter product, around equator it will be 10 meters, and going far away from the equator it will be 10.1, 10.2. It will little bit expand. So after projecting it, you can get the X resolution and Y resolution. So once this is done, I'm going to iterate over each of the polygons and then compute the zonal stats out of it. Okay, now you can ask me, hey, if you are iterating, are we not using the fullest of full power of Planetary computer or the X-arrays? So X-array is a system that works well with raster. For example, if you have a 12 raster image, those 12 raster images, if in case you want to find an NDVI on it, you don't want to iterate it. You can easily do an NDVI without even iteration. But here we are dealing with a raster and a vector. So the best solution I found is using this, using an iterate, but still it worked. Once this is done, and the rest is in simple Python operation where I am going to assign each class its value, and then convert it into one pandas data frame, and then export it as in CSV. While this is being processed, here you can see how the bottom, you can see how much memory is being used. For example, if we are pulling more than 32 GB of data, your RAM won't support it, or if the process won't support it, it will turn red and it will fail. So this is one of the limitations as of now. If you're doing it for a large extent, for example, if you want to do it for Tamil Nadu, if you change the bound for instead of Delhi, if you're doing it for Tamil Nadu, you'll be pulling a lot of data and you'll be like storing it in your RAM for processing. Obviously, this is going to fail. If it is in the commercial use, if you're having a larger amount of data, then obviously you can do that. Okay, now let's inspect this CSV. See, for each district we have like trees, shrublands, whatever the particular land cover type is available. It has chunked out the area for it. Maybe I can address any questions if you guys have in this workflow. It might be a simple workflow, but still, in starting point, you can like use this. Great. So maybe I'll just pause for 5 minutes. You guys have access to this notebook. You can like try. If you are having a different geo package, load it and then check whether you are getting that result or not. And if you are having any doubts, feel free to call Aman or myself. We will come and solve it for you.
Yeah. 11:30.
Okay, I hope everyone at least tried something. Anyone got result? Like, did you complete the workflow? Okay. Anyone got into error? Do you need more time for debugging? Okay. The silence, I can take it no. So, correct. Okay. So now we saw how to use the Planetary Computer Hub and Planetary Computer API to retrieve the data. This is one of the way to get access to the data catalog actually. There are many more ways in which you can get access to this particular data. I am going to show you another way. I think most of you have used QGIS. So you can stream data from the Planetary Computer data catalog into your QGIS. So that is one of the most coolest. You don't have to download. You can just stream the geotiffs directly to your QGIS. So when I learned about this, it was so fascinating for me. When I was in my university, I used to download GBs of data to just process one single city. So this is like really super cool stuff that is being built. Okay. For that, you need to install a plugin called STAC API under plugins. When you go for manage and install plugins, you can like search for STAC. You can see it's in STAC API browser. This is built by Cartoza. So they are one of the huge contributors for QGIS. So they developed this. And once this plugin is installed, you will have an icon like this in your ribbon. When you click on it, you will get an interface like this. In this interface, it's just not just the Planetary Computer. You can access more data. But for this session, we are going to stick with Planetary Computer STAC API alone. You can also, if you are having URL, you want to add new connections. You can also use this to add it. And once you've done this, I'm going to search for Sentinel. And I'm going to give fetch collections. As you can see, now we got all the products of Sentinel. Whatever you want to, whether you want in Sentinel 1 product or you want in Sentinel 2, you can select. So I'm going to select Sentinel 2A, and you can give the filter by date. So you can select the date actually. So I'm going to select, oops, not the future, May 1st to May last. So it should be June 1st. And then since we already have the geo package loaded in our background, I'm going to set layer should be this map canvas extent. or you can also have some drawings if in case you want. You can like draw using this draw canvas. And next what I am going to do is I am going to do the data driven query, not the data driven, actually the advanced filter. So here I am going to write a filter which is going to say I am going to filter for the images which is having cloud cover less than 20%. So for this filter you can come to this Planetary computer page, because I really don't tend to write code. I used to copy paste code always, so I will like take the written code from somewhere. So if you come into documentations, go to some tutorial using this Sentinel-2. You can see how this query is done, like EO cloud cover LT and particular percentage what that needs to be like given 25 or 10 whatever. So you can copy this and I'm going to leave it here, and yeah, we can give search. Now this will search the Planetary computer data catalog entire and it will give you the matching images. So once these images are loaded, you can actually see this footprint loaded in your QGIS canvas. So this is our QGIS canvas. You can add all footprints, and as you might have used this Sentinel-2, you knew like partially this image will be passing through ROI, like that. Even before downloading the data we can check this. So you can just click add all footprints, and now you can see all the footprints are added as a vector. You don't want to download it, you just got the footprint. You can make an analysis and then find okay which image you want to download. Then after making your decision, you can come here, select that particular asset, and then you will see okay whether do you want to download which band 1, band 2, band 3. So I'm going to do this RGB, red, green and blue. So yeah, select as add as in layer. Now this will add as in layer. So when I click this, as you can see, now the data is being streamed into this QGIS. This is a real GeoTIFF, not just some like processed one. This is a raw GeoTIFF. You can use it for analysis. So this is a very cool use of STAC that is in QGIS that is using the Planetary computer data catalog. Great. So yeah, and from here you can create an composite or whatever you want to do, all the QGIS analysis you can do. Any doubts on this? Any clarification? Okay, okay, that's it from my end. So these are the things I just wanted to show you with related to Planetary computer. Great. So now before moving into the next session, maybe we will take a 15 minutes break. Where is that? Okay. Okay, in this 15 minutes break, what we can do is we can do a networking session. So what we want to do is we want to introduce you to everyone, and you also like know the other person, so you can like get a better understanding of other person and maybe make friends. So from Raghavendra, maybe you can start.
Hi everyone, I'm Raghavendra SP. I just completed my master's at Remote Sensing Application Center in UR Politics. Now I'm working as a project associate at Planetary. Thank you.
Everyone, I'm Kevin. I'm quite simple company. I'm somewhat I'm a freelancer in GIS services. Look forward to all of you. Thanks.
Hi, I'm Suri. I'm working at Remote Sensing.
Hi, I'm Satyukt. I'm working in Spatial as BI analyst.
Hi guys, I'm Satyukt. I'm working as Remote Sensing engineer in Satyukt Analytics.
Hi, this is Abhishek. So I work as a salesperson in Satyukt. So as we are dealing about this data and also I was enthusiastic, so I just want to learn it. So it's the first day of me doing this. Thanks.
Hope you enjoyed it.
Yeah, definitely.
Hello everyone, myself Precious. I'm presently working as a product associate in Karnataka State Remote Sensing.
Hey, myself Dimple. I work as a geospatial engineer in Pixel, And to the start, I got to know Aman with the electrification part. And this year, I went for the STAC community itself in Philadelphia.
She can also be a guest speaker.
Hello everyone, myself Manish. I work as a remote sensing engineer in support.
Hi, I'm Ramesh. I'm working with VA Senior in support.
Hi, I'm Abhishek. I've done projects in geospatial, but not in working in this domain, just experience.
Hi everybody, my name is Amrut. I'm a senior researcher at the Indian Institute for Human Settlements. Mostly deal with big data, policy making, things like that. Also with the organizing committee for STAC.
Hello everyone, my name is Aman Bagracha. I'm working as a geospatial scientist at Galaxy Space, based out of Bangalore. Also part of Let's Talk Spatial from past 1 year. We have been organizing for 1 year. This is the 12th time we are doing.
Class for us.
So this time, because there was some conflict with other conferences as well, so that is why, but anyway, the recording is live and you will have access to all codes after the presentation.
Great. Okay, now this presentation is done. Next is going to be done by Aman. He is going to explain about the STAC in depth. So he is also having some hands-ons. Let's welcome Aman.
Cool. So I'll go, this will be an interactive session. I want everyone to understand STAC, and there will be just few lines of code, but everyone should implement. And you can implement it in any platform that you want. It's not restricted to Planetary computer. The reason we chose Planetary was all packages were already installed. That is why we did not want anyone else to figure out things, how to install packages and all of this. So let us start. So basically why we are doing this is, there is one thing in geospatial which is the standards part, which is not unique. So what happens is, every time, you might have seen from past, I don't know how many years, people have been querying data in different formats. So if you want to download Sentinel, there is a different API. If you want Landsat, there is a different API. If you want Modis, I don't know, how do you download Modis, So there is this reason that people have come up with one standard, and what their thought was, we'll have one specification and people will follow that as well. So this is one SKCD comic which says that you have 14 standards already, and when you introduce another standard, it becomes not one but another extra. So that is what was the intention. That was not the intention. Hopefully STAC has taken pace, and that will be one standard what everyone will follow. So the only reason STAC exists now and is so popular is because of the ease of use and also the community. So the goal was to have interoperability, so that you just have one API, you query everything, and you don't need to be an expert in how do you download data. You want to focus on the science part rather than querying data. So this is just one demo what STAC brings into picture. This is how you consume STAC. You don't need to know the specifics. I'm just telling that this is small line of code that will help you download Sentinel data over this time frame and over this coordinate. So if you specify, and there are some additional parameters that you can specify, say that you want a cloud cover less than so and so %, or you only want Sentinel 2 in ascending powers, or Sentinel 2A only and not 2B. So all these things you can actually specify and get the data for that particular area of interest. So now what all collections are available currently? So we can look out for that in STAC index/catalog. So let us do hands on everything now. I'll just tell you. So if you go to STAC index/catalogs, let me just zoom in. I want everyone to just understand. Only I'll take small part, but understand everything. So everyone has to go to STAC index/catalogs, where you will find a lot of catalogs. Now catalogs are basically, people accumulating data. I mean, each data has a different format that they publish in. So say Sentinel, ESA publishes in their own catalog, Landsat will publish in their own catalog. So you have so many more catalogs. Say any private company, say Capella Space is putting their own catalogs here, so that everyone can access. Now on the right you see two buttons, which is catalog and public, or API and public. So these are the only things you will see. Now what it tells is, when you see catalog, it is a static catalog, and when you see API, it is queryable, it is dynamic. So by that I mean, you can search through the entire document of, I mean the catalog is a document itself. You can search through using an API when you have an API in place, but when you have catalog, you have to query manually. Now a lot of times what happens is, your ultimate goal is, when you search on Google, you need to search the Sentinel-2 imagery over this date, and you should be able to get back the result, say an asset. So that is the ultimate idea that we want. That can only happen when you have an API. When you have a catalog, you have to crawl through by yourself. So a lot of catalogs are still static and not dynamic. Now what I'll show is, let us start with the specification. I want to give an analogy of what STAC specification is doing. So STAC has 4 components, which is catalog, collection, item and assets. Now think of you as a librarian, and in your library you have one library building, you have one room in your library, you have a lot of sections in your library and a lot of books in each section. So the specification is basically that. So catalog is your library itself, where you store books, where you have many sections. So that is your catalog. Catalog is a document. Then you have collections. Collections are basically a specific section of the room. Basically you have history section, you have science section. So these are the collections. Item is one specific book in each section, and an asset is the pages of the book. And how does it correlate with satellite data or drone data? So catalog can be, say ESA is producing Sentinel data, so that can be your catalog, and collection can be multiple data sets that ESA produces. So those are the collections. And item is basically so Sentinel has many bands, right? It has 12 bands, so all of them are accumulated in one item, and asset is each band itself. So that is the specification that STAC is going for. Now interestingly, so what you will see here is all these are, so catalog and collection is a JSON type, and item is a GeoJSON. So I'll show you an example. How does a catalog, collection and item and asset look like? Let us go with Sentinel-2. So this is a catalog. Okay, so in this catalog, if you want to, let us open the catalog. I don't think so it's visible. Let me just. So I've gone to Planetary Computer and one of the example notebooks, and if you so this is the API of Planetary Computer, and this is their catalog. So Planetary Computer as a company is hosting many data sets. So that is the catalog, and many data sets in the sense it is hosting Sentinel-1, Sentinel-2, and those will be collections. So this is the type catalog, and if you go in, you can see a lot of collections. Under each section you see that this is Copernicus DEM, which has API as v1/collection. So you can see that I'll just zoom out. These are all the collections that this catalog is holding. You can see COPDEM, GLO30, HGB, and if you search for Sentinel-2, you can also find that as a catalog, sorry, a collection. And again, that is a JSON item itself. When you click on that, you go into collections. And so what we have done is, Planetary Computer is hosting a catalog. In that there are many collections. In each collection you will find a lot of items. So now we are in Sentinel-2 collection, and in that you will find a lot of items. You can see here that we are /items. There is an endpoint here, /items. You can click on that and you will find a lot of items. Lot of items in the sense, like if Sentinel passes today over our region, we will have one item for our region. So here you can see, let's just zoom out. So this is one of the items that we have played, and you can see a lot of bands. So these are the assets. AOT, B1, B2. So all these assets are present here. And I can actually go ahead and copy this entire thing. Let us not do that, I think it will crash. And load it in a geojson.io. So you can see that, so these are the tiles or the items which are there in the collection Sentinel-2. And the limit, we have set a limit, so on one page only certain items will be displayed. So that is why only few items are being displayed. But essentially what I want to drive home, the point I want to drive home is, these are basically GeoJSON which has the bounding box, like the tile over which your satellite imagery will be present. So this is a GeoJSON. Now, so this is the core concept of STAC specification. Now we'll go into three important parts, which is producer, server and consumers. Now what has happened, the reason why STAC is popular is because of the community and the tools it has developed. So there are three components, which is producer, servers and consumer. Producer, say your company, you are a private company which is building satellites and you want to disseminate data. How would you disseminate data? In what format? In what specification? Say you choose STAC as a specification, but how do you create a catalog? For that you have a producer section which is on the top. These are the tools which will help you build that catalog. Say you have created your own data, you have some SAR data that you want to publish. So what you do is you use these tools and then create a catalog and then publish. But how do you publish? When you produce the data, that is your static catalog. You are just serving to yourself. You are not like giving it out. So there are servers, which is STAC servers, STAC Fast API servers, which will help you to disseminate data in an API format. Like you can actually query the data. So that is the server layer, which the producer does and serves to the entire community. Like if you want to download the data, now you can go. So all the APIs that are present on the STAC index catalog have some sort of server hosted. And then there is consumer part, which an end user would use. Say a PyStack client, STAC assets, all these STAC will consume that API. It can also consume static catalogs. So majorly there are a lot more people in consumer than producer, because private companies or government organizations are quite limited. So we'll focus on, I'll just give a small demo which everyone can try using how do you create a catalog or an item, and then we'll focus on the consumer part. So let us start with this. So let us create a STAC item. So item is basically, as I said, is a GeoJSON which contains additional information about your data. So Sentinel-2 over say our region today will be one item. So let us create that. There are tools which will help you do that. Few tools are RioStack, Stack Tools, PyStack. PyStack is Python library. These are command line tools which you can use to create that. So to do this example, either you can go to your Jupyter Hub and or Microsoft Planetary Computer and type this in, or you can actually go to Colab. If you just type colab.research, everyone, it is free to use for everyone, and click on new notebook. So here you can actually type in the entire command. I'll share the slides as well so that everyone can, don't have to and let us do an example. The first time that you run this, there obviously will be an error because the library is not installed, but let us just try so that we get the command. Okay, so it says that you don't have Rio installed, and we can go ahead and install it. Rio is RIO, which is Rio is basically rasterio. It has a command line tool which we can actually, it supports STAC as well, which will help you out. If you have Microsoft Planetary computer, it is already installed. You just type in this command. So here I would do pip install. Just zoom in. Pip install rasterio and in quiet mode. So I'll just do this. I hope everyone is trying out so that you can just get a feel of how a catalog would look like. So how are you creating a catalog? If you see the link here, Sentinel-3 cogs and blah blah blah, whatever is there, but the end is one band, b11.tiff. So we are converting a tiff into an item of its own. So that is what we are doing. This is the simplest way that you can do. Just call RioStack and the asset, or you can also use PyStack, but that is for another. So now what we'll do is, let us just remove JQ and the pipe and run this command again. So there is no command as stack. Oh, sorry. So you have to install RioStack. So this is the Python library that you have to install. My bad. It might not be installed on Planetary computer as well, but this is the simplest way that you can install. Just on your Jupyter hub, just type pip install RioStack and library will be installed. And now type in RioStack and the asset. So there you go. So it created a GeoJSON which is the item of the asset that you just passed in. Now you can copy this and paste it in GeoJSON.io just to see where the image is located. So this is just, will provide you a bounding box. So there you go, this is the image footprint. So you just created your first stack item. It is so simple, just pass in RioStack and the asset, and there you have your RioStack, your stack item. If you have any questions, please ask. I don't want to complete the entire section, just want everyone to get familiar with this. Cool. If everyone has tried, I'll just tell last time, just install STAC and run the command. If you are stuck somewhere, please ask anyone. Now let us focus on, so there are two parts, one is STAC specification, one is STAC API. What consumers are interested in STAC API is basically when you want to create an LLM just to fetch your satellite data. When you type in Sentinel-2 over Bengaluru for 22nd January, the result that you should get ideally should be an asset of Sentinel-2 over my date range. And this is what the overarching goal of STAC API is. That is what we are trying to achieve. And to create this, we have already discussed about STAC servers and producers. Now once you create your item, you have to validate so that it is according to the specification. And to do that, you can either do pip install STAC validator, install that and then pass in your URI, or directly go to the stacklint.com, which will, and when you pass your URL or your GeoJSON, it will tell you if it is valid or not. Let us try the second option first. So stacklint is, you can either pass in your GeoJSON here. Let us try passing in the output that we got from our item and see if it is valid or not. So I just passed in my valid my item, and see on the left is a GeoJSON that I have passed. I click on validate. So it says that it is a valid spec, and it also says what is it. Is it a catalog or is it an item or is it? So it is saying that, and also what schema it follows. So now you can say that your item is valid and you can actually publish it online or give it to the end user. So what you have done till now is you have created an item, STAC item, you have validated it, and now suppose you want to download it. But the entire goal of doing STAC is not to download any data, but there are some issues that I found is people create STAC catalogs but don't put it in cloud native formats, and that is the reason you might have to download the data sometimes. One specific example is Landsat Look, which is from USGS. If you try to query the data, it is not in cloud optimized and you have to download the entire scene, and that is where. And another reason is there are some authenticators in between that you have to pass through, and that becomes a hassle. So not just clicking on the link, you can't download the data, you have to pass a barrier, login, enter credentials and do all of that stuff. So that is why STAC community created another Python library, STAC asset, which will help you download the data. So this is a command. You again, I am not running this, but if you want to download the data, you just install STAC asset and then pass in this command. What it is doing is, this is your API, Planetary computer, and you are telling that I want to download Landsat data and I just want to download one data, then you pass in your STAC asset download. So it will download the data and also the item, that it is telling that the associated metadata for the asset. So this will help you download the asset as well. But remember, you don't want to download data. That is the entire reason STAC was created. You don't want your data to be processed on the cloud itself and not on your local machine. Again, so this was the API that Santosh demonstrated, QGIS API, and I come to the last part, which is STAC and cloud native data access. What if you are a producer of data, you have to ensure that you should not just follow STAC specification, but also the data should be cloud native, meaning that it should have. So what is cloud native? Cloud native is basically you only want to download or fetch that amount of data that is required for you and not the entire region. So that is the whole idea, is to just transfer minimal amount of data from cloud to the client. So that is the whole idea of cloud native. Unfortunately, a lot of existing government and private organizations still do not have their data in cloud native formats, and you still have to download the entire scene, and that is again not good for sustainability point of view as well as for your financially. And finally, if you want to create catalogs, say you are a producer, these are very good links from STAC documentation itself that you can refer to for creating your catalogs. So so now we'll focus on the consumer part, which is everyone here might have downloaded Sentinel data, and you might have seen that you might use Sentinel SAT or SAT search or all these libraries, and you might have downloaded the entire data on your local machine, maybe GBs of data from by clicking the buttons and then downloading the data. So that is what we usually do, used to do previously, but now I think it's demo time. So let's take one example and we'll finish things off. So there are, I'll focus on the second one, which is Mosaic, so that you learn a little bit more as well. But the other example, I think I'll leave it to you guys to explore. So let us.
There is one question. You want to answer it now or later?
Sure, now sir.
So there is one question from the chat. Okay. Can we add a custom address to the new stack?
Custom
address to the new stack. Can the stack link can be customized? I think this is what we mean.
Domain name.
Can we add a custom address to the new stack?
New stack.
Yes.
The new asset that you created.
In your asset you are creating as a stack, the address be customized. The hyperlink address can be
Hyperlink can be customized. So I'll show you one example, which is Landsat. So this is one again APIs by Landsat look by USGS. Again, if you see the URL, it is not in some specific format. You can have anything, but the format should be that you have a catalog in the top, and then you have say a collection or a catalog or item. But you can have any hyperlink. That the address is not an issue. So here again, if you see, this is a catalog stack server. Another example is Earth Search. If you see Earth Search, so this is another API by another provider. Just like Planetary Computer, you have some other provider also having their API hosted. So you can have USGS or Earth Search. So you have to you don't have to look at the document. This is for the machine. What you have to do is, if you are a producer, then you care about this. But if you are not a producer, then you want to care is the consumer side. How do you consume the data? But yeah, I think if that was the question, if the hyperlink is, the address is mandatory or some format, there is no format to that. So let us now let us go to Planetary Computer, and I'll just show you one example. Again so Planetary Computer is just for everyone's ease of use. You can do it on your local machine as well, and say any cloud provider, does not matter. Let us do mosaics. So now what we are going to do is, everyone knows about Sentinel-1 data, which is SAR data, C-band SAR data, and what we want to do is create mosaics. And you might know that Sentinel-1 data is quite heavy, each band having 1 GB of, approximately 1 GB of size. So if you want to say do a composite or create a mosaic, you can think you have to download a lot of data if it were not for cloud computing. And that is what we learn in this workshop. I'll just share the link to this as well. on the Slack channel. So I think if everyone is on Planetary computer, we'll just run, just show you what the power of, can't open. Or you can directly give the file itself, and then you can download and upload it on your. So now I've shared the Jupyter notebook, and you can run there or on Google Colab as well. So now what we'll do is we'll run the process. So these are the standard libraries. So PyStack client is basically a consumer library which will help you query data or search data from the API that are already hosted. And where do you find the APIs? You find it on STAC index/catalogs. You find all the list of catalogs that are hosted on STAC index. So once you identify what you want to, which API you want to use and which data you want to use, you can go ahead and run this program. What we'll do is we'll just install. So these are standard libraries. UXarray, GeoPandas are not necessary as of now, but Planetary computer is basically for signing in the data, and PyStack client is for the consumer, which is how do you consume the data. Now, this is the interesting part, which is you have one API, you are calling Planetary computer, and you are also passing in the area of interest that you want, your mosaics, and the time of interest. Then you are giving a search call to the data that you want. In this case, we are using ground range detected of Sentinel-1, which is just the amplitude and not the intensity, because Sentinel has both intensity and amplitude. Here we are only using the ZRD product, then also passing in some additional parameters so that to limit the query. And you are saying that I just want my orbit states to be descending, because there are two satellites and both are Sentinel-1A and 1B. Unfortunately 1B is not functioning now, but you can pass in ascending and descending orbits so that you have overlaps. When you are doing say interferometry, you just want one pass and not ascending and descending. That will cause errors. So then you, after searching, you just run this and then it will fetch you the items after matching the query. So it returned 35 items. What it says is, I found 35 Sentinel-1 imagery over my bounding box for this time frame, given the parameters that it should only be descending. Once you do that, then there is one simple GeoPandas code that you can run and see where are your satellite imagery are. So I'll just run this data frame. Here you can see your footprints of Sentinel-1 imagery that you queried. So I gave this bounding box and it found all the intersecting Sentinel-1 imagery over this region. And then if you hover, you can see the metadata properties as well for that specific Sentinel scene. If you run, now it fetched 35 items and we are just querying one item from that just to see what the hyperlink looks like. So here you see the item. Inside the item you will find, I think I have to close a lot of tabs. Yeah, so in this item you will find a lot of properties about the satellite. So here comes the interesting part. So STAC has something called as extensions, which is again not part of the core STAC spec, but an extension itself. That is why it is called extension. So basically, if you have Sentinel-1 data, there are some other additional parameters that you pass. Say you want, so all these properties of Sentinel-1 do not necessarily have to be for Sentinel-2 because the properties itself are different. So in this case, if you see, Sentinel-2 won't care about having S1 resolution or having say look angle or spacing range. So all these are specific to Sentinel-1 or say SAR as a whole. So there is one extension called SAR which is applied to Sentinel-1 in this case, so that it follows some standard. Similarly for Sentinel-2, it has EO as an extension, which is electro-optical, which provides some standards that you need to provide these additional metadata so that it can follow the specification. And there are many more specifications such as proj, which is projection information that you are providing, or it can be I think filters, or if you can look at, just go to STAC extensions and you'll find all the STAC extensions that are available. So here you can see a lot of extensions which are there. There is projection, there is template, virtual assets, render, scientific. The list goes on and on. So this is a huge list. So there is data cube. So there is one extension for each, and it is only, so these are applied to specific data set. It does not have to be applied to each catalog. Now what the problem is, and I have reported this to my Planetary computer as well just yesterday while I was doing this. So Sentinel-1 data, so when you are trying to mosaic, it requires projection information, and unfortunately Planetary computer that was the data hosted in Planetary computer does not have projection information associated with it, and so that is why only Sentinel-1 product, Sentinel-2 has proj associated, Sentinel-1 does not have. And how do you see which extensions are applied? So you go here and then there is a link, STAC extensions, which will tell you what are the extensions which have been added to this catalog. You can see a SAR extension, a SAT extension and an EO extension, but proj extension is missing. So if it is missing and you want to mosaic, so because mosaic requires spatial information, you need to add proj extension by yourself because it is not added. But we can tell Planetary computer to add it, and hopefully they would in the next release that they do. So this is how you add. You have to define three important parameters, which is what is the EPSG code, the geometry and the bounding box, and the transform. So this is a little complex, but I just want to tell that if some extension is missing, you can add it yourself even after the API is hosted. So this code will just add a proj extension, which is item.extension.add proj. You are adding the proj extension and then inserting the data to it. Now let me run this. So it is saying item, okay, wait one second. For some reason it is not working now. Huh? I think they might have changed something, but yeah, if that does not happen, let me run it in local and show you. Yeah.
When it goes to local,
Yes.
the screen will not be visible.
YouTube screen on
Not that.
Okay, got it. I'll just change the. I'm going to browser itself, so I think shouldn't be a problem.
From the browser you can see. But whatever you are doing in German, you won't be able to do.
Yes. I have to figure out why this is happening, but when I ran it locally, so let me just quickly run this. So I'm running the same code, which is, so this is just to show that you can also run it locally if you have packages installed. You don't have to necessarily depend on Planetary computer. So now it is running. You can see the dots. It is completing for each item, which we had 35 items. For each item, it is adding the extension, pros extension. And then the power of STAC and cloud computing is that you can also display it on the fly. Now we are just using an hybrid called Rio X-ray and just passing your href, which is your hyperlink to the data, and also loading the image. You just see where the image is. And if you see this image, at first it looks like a normal image, but what has happened is it is descending and not north up. And how do you see this? So there is water on the right and land on the left, but if you go to all the items that we just fetched, you see water on the left and items on the right. So you can see this has become upside down. And why this happened is because Sentinel-1 we queried for descending pass. So that is why the image was not north up was it's upside down. So you can actually do a little magic and then make it. So that is the task for you. It is not something very important, but just to tell the point that Sentinel-1 descending pass has upside down image. And now comes the good part about STAC and cloud computing is there is such a good tooling around it that now you can mosaic with a small library called STAC and then stack all the images together. So all the 35 images that you queried, and now you want to create a mosaic that you can do with just this line. You just have to pass all the items that you queried and then also the EPSC code. So if you pass in and then see the result, you see it might be scary to see first. The image size is 698 gigabytes. So such a huge amount of data. How will we even process it? And but this is the entire item that it collected. Now if you want to run this, then you can use something called as, that is the end of, now we can mosaic it. It has already, you just run the next command, which is ds.compute, and it will start computing your mosaic. But up to this point, if you were to do it on a local machine, it was not possible because you can't download such a huge amount of data and then do it. Now with Dask, with parallel computing, you can just load many instances and then run on each to just compute the mosaic and then get back the data. Here, after doing all of this, it will chunk. On the right you see small chunks, which is what is passed to each task cluster, and then it computes for that cluster and gives back the data, then joins everything back. So everything happens on the cloud. What you get back is just one mosaic, which will be of small size and but it has to compute 698 GB, and you can't do it locally, but can be done on cloud. So that is the end of this tutorial as well. Or there are two more tutorials, but we'll leave it for some other day. But I'll just go with that you can also compute NDVI on the fly. I was doing it this morning, and then within minutes you get this result. So this result is for Bangalore. I just gave a spatial bound and said that compute NDVI over this region, and again using STAC. If I just show you this, so I had 13 images of this size. I just computed it very quickly, and it gave me, for each image it gave me one image. Each 13 of the images it gave me one plot. So I highly encourage everyone to explore STAC. So once you have some understanding of STAC specification and STAC API, then consuming it becomes very easy, and there is a good community out there that you can just go to STAC utils. I think one thing that you can take is be part of the community from this. Yes.
Before going to something else, is there any library for the core registration of Sentinel 1 and Sentinel 2 stack?
There is no library, but STAC will help you. If the data is overlapping, it will automatically resample your data and then provide. You can do additional aggregations operations, say mean, median. So these operations you can do, but there is no pixel-wise core registration is not possible in this.
He's interested in SAR and multispectral.
Yes. SAR and multispectral also we can do. So basically what happens is internally is just array. You just resample and then place both arrays on top of each other. But pixel wise co-registration is not possible.
So do you know what is the algorithm behind the mosaic is happening when there is an overlapping between two images are there? So what did you take? Did you take a mean or the first image?
Yeah, it takes the first image.
Is there an option to customize that?
Yes. So you can either do last image first or the first valid pixel, or you can actually do your own custom mosaicing operation as well. And these options are available if you just go to STAC. And see for more examples. I think there is internal API references. Okay, so mosaic. Under API references you will see mosaic option, and here you can pass in. So STAC provides only two options, which is the first image will be the valid pixel or the last image will be the valid pixel, but raster IO provides many additional options.
So we can pass the stack into raster IO to do the mosaic.
Yes.
Clarify on the little more. So mosaic means it is like stitching two images. You are not computing any statistics out of it. So for example, if you want to do statistics like an median, mode, it's like a composite. So it's not even a mosaic. It's a composite image.
No, that's what. So generally when we do mosaic, right, we will do take. See, there are mostly, as you were saying, there are many packages nowadays which do advanced of what the traditional mosaic does. Okay, so you can do something instead of mosaic. I can use a merge option where I can choose instead of giving me the first point. When I talk about the GDAL will be run from the terminals, so I can use a GDAL merge. So there I can do maybe take the mean or median. So this is the question.
But still, if the mean and median comes into play, the statistics, right? Like we are computing some kind of.
No, it is just you are joining. So when you are joining a multiple images into single image, right? The user is not going to do just I want the first image to be. Sometimes my use case may be something which demands when there are two images. No, I want to take a mean of it. So it's just a use case what we need. It's not a technical term of what is the meaning of mosaic. Okay. It's what is the use case we need.
Correct. So these are the options also available when you do a merge. Merge basically mosaic. So you can actually either, so you have many options. You can take first pixel if both are overlapping. You can take first pixel, you can take last pixel, you can take the count, or you can also take the maximum value or the minimum value or the sum. So these are the options available for mosaicing.
So the another question which is follow up to your earlier question, where the customization of the link, right? So the question was, I think, he is asking this stack server for creating a stack assets. Can it be done from a local system also?
Yes.
You have to lay on a stack server.
So you actually do. So what happens? I'll give an analogy. If you are a librarian, the basic, the point that we started in, you initially start with creating your own catalog and you create on your local machine. So basically like a librarian will put books in a specific shelf, and then maybe a computer system comes in, then he queries, okay, where is my book? So that computer system is your STAC API that is hosted online. But what happens, as a librarian I am cataloging my books, I am putting it manually. So that happens locally also, or you can put on S3 bucket and then just give an hyperlink saying that you can fetch my catalog. So that won't be dynamic, it will be a static catalog.
So is there any need to have, I don't know, need not to do, but if possible he is asking you to share some documentation link for this. Maybe in the later stage if you can share in a Slack or
all the documentation that you should.
But I don't think right now you may not be having, but you can just, if you have.
I'll just point to few things, few resources. Yes, SpiceStack is a good resource. I think if someone wants to develop their own catalog, if that is what they are asking, they can go to SpiceStack docs and under tutorial section you will find a lot of a very good tutorial section, starting with how to create STAC catalogs. That is basically if you have your own data you can create locally or host it. So again this is very good documentation, also explaining everything. And then if you want to add custom extensions, they also have how do you read data from STAC. So here they are using all these extra libraries. But yeah, documentation is quite good. One link is SpiceStack, other is the GitHub channel STAC utils. Again the same diagram that was, so this is the if you are a Python developer, or this is not just related to Python, but this is Python specific. There is another link which is STAC STAC site. So here you can see most about, I think, where is it? Oh, I think there was one link. STAC spec, I think. So there is also STAC site, I think that is the same, but there was one, okay, yeah, it is STAC index. So STAC index is again a very good resource. Here again if you click on ecosystem, so this is one page I would highly recommend everyone look at. You can filter based on your language and what you want to do. Say your language is just Python, just click on Python and all the associated resources for Python will be displayed. And specifically if you want to search for some extension which is implemented by the producer, you can click on those. And if I want to say do a validation, I just click on validation, I click on Python, and then if I see these are the validators that are available for me. This is the one I mentioned in the presentation, but there are other validation methods which may not be specific to Python as well. If you just click on all programming language, you can see so many. Say you have a node validator, so it does not have to be Python specific, but this is a great resource, STAC index. If you go to, I mean the best part is the documentation is very good, but there are many places that you can actually visit. So one link is STAC index, one is stacspec.org, I think.
Just can you post these two into Slack? That may be useful for others too. These two links, whatever the documentation links here.
So I think these are two good, and again this GitHub repository. I think if you look for these three, I think all the, and also SpiceStack documentation. under the tutorial section. If you learn from this, I think you'll have a much better idea about what the specification is and what is happening. So also, if you want to be part of STAC community, there is every Monday or Tuesday, every second alternate Monday or Tuesday, there is a community meetup that happens online, where you can join and just ask questions or see how the community is developing STAC specification. So yeah, that is that, and I think I'll just take questions. That was the end. If someone is like interested in how OGC and STAC are being aligned, there was a great talk by Matthew Elson in Phosphorus 2023, where he actually said if you want to use, if your data is if your feature, which is your GeoJSON, is the data itself, then use OGC features, and if your GeoJSON contains a link to the data, then use STAC. One great example that he gave was if you want to train machine learning models, then STAC is not a good place to host your training samples. OGC features will be a great place to do that. But if you want to see how these both are aligned, there is also a community for OGC, which is Open Geospatial Consortium, which is taking up the initiative of including STAC and OGC and aligning them both together. But yeah, I think that is it. If you have any questions, like want to get involved, I'll share all the other notebooks as well. Just format it and see if they are running, and then I'll share it with you. But that is the end.
Any questions? Go to the next talk. No questions? So thanks everyone.
Thanks.
If you have any questions, you can always contact comment. You can, it will be available in Slack or these Twitter channels, wherever you want. So next. There is one question from YouTube, okay, for Santosh. It is regarding before the next talk, just I will ask this. So can you explain the query for land cover part of the script? So in your
Okay. So regarding the query, so Aman extensively explained about that stack, how to write that API and how to get the call. But I will just show you again, and then I have one slide. I will just show where to go from here. Since Aman might have like bombarded with lot of technical things, and you would have explored the Planetary computer for the first time. If in case you like, okay, this is so cool, where can I start? So I'll just show you some references where can you like look for and get to know more about these things. Okay. Sure. Okay, so regarding the querying part, this is a simple query that is going to fetch the data from the Planetary computer data catalog. So first here the client.open will get the catalog database, like what all the data is available, so you can get that, and then catalog.search, what collection you want to search, that you should pass, and then what is the bounds you want to get. So that will particularly fetch that tile. So once you get the search items, you're going to say get items. Get item will say, okay, what are the available items in that particular search. So as we saw, we got 2 items out of it. What are those 2 items? That is that 2020 land cover, 2021 land cover. So this is, I think this is very basic, and this notebook also will be shared for YouTube audience. Maybe we will add it in the comments. You can get it from there. And no? Sure. My presentations. there. Presentation bro. Oh. Okay. So the final thing which I'm going to say is, okay, you guys are bombarded with like many stuffs. Where can we start learning this? So understand STAC API. Aman will have produced like lot of resources. You can just go and read. Instead of like watching tutorials, I would suggest reading it will help you. And then learn about X-ray and parallel computing. There is one resource which there is actually one course that is like hosted in GitHub, where you can understand how X-rays and parallel computing can be used for environment modeling. So basically geospatial stuff. So that will be very helpful. And Azure clouds. So if you are available with any other cloud like AWS, Azure cloud is again it's going to be easy. But do sign up for this GitHub discussions. As Aman said, if you find anything that is not correct, but in particular with the Planetary Computer Data Catalog, you can post your questions here. So one way I got very used to Google Earth Engine is by answering questions in developers community. So once you start understanding this Planetary Computer, start answering others' question. So eventually you will get to like be an expert in Planetary Computer. So this is like monitored by experts in Planetary Computer. Tom is always answering questions. So you can see like at least in a day you will get 1 or 2 questions and it will be promptly followed. So these are the things I'm going to leave you up with. If there are any questions we can take, or yeah, we can take.
You can ask. So I think no questions. You can, any questions you can ask later also. Okay. Yeah, thanks Aman and Santosh for the very nice hands-on session. Next we will have Amrut, who will be giving a little overview about the December Ingress 2023 event, what it is about and what you will be getting from there. Over to you, Amrut.
Okay. Hi everybody. Hello. Nice to meet you all. I'm Amrut. So basically, this event is also a curtain raiser for the India Geoscience and Remote Sensing Symposium conference that's happening in December, and it's going to be hosted at IIIT Bangalore, the International Institute for Information Science and Technology. It's in Electronic City. So the conference itself, obviously, I'm not sure how many of you are into academics and industry sort of bridging events that are conferences within geoscience and remote sensing. And the INGAS is going to be the first in-person geoscience and remote sensing conference to happen for the first time. So before it was online, but now it's mostly going to be in person as much as possible. And the big deal about all of this is that we have a lot of folks who have presented and who are coming as keynote speakers for the conference itself. And we'd like to have more participation and your interest as well. And the main agenda behind all of this is that we have folks across academia, across industries, and we have sponsors from ISRO and NRSC, Satyukt, Galaxy, and as well as Let's Talk Spatial and the OGC, the Open Geospatial Consortium, are knowledge and technology partners. So as technology partners for the conference, we will do events like this, and this event is also jointly organized by the IEEE GRS's Bangalore section. So students out there who are interested to be a little bit more, diving deeper into geoscience and remote sensing, we recommend you to be part of the IEEE GRS's Bangalore chapter as IEEE members. It offers you a lot of benefits to network amongst people like us within academia, within industries. It's a really good opportunity to be part of events like this as well. So basically we have also like keynote speakers from Dr. Harini Nagendra, Armando, and Rashmit Singh from Satyukt as well. And the list will keep increasing as and more folks come in, and this is just the initial, let's say, plenary talk and tutorials part. Tutorials we have Dr. Carlos talking about SAR polarimetry, LULC detection with Ujjwal Gandhi of course. And then also very specific to today's event, we have something more on the standards of analysis ready data by Dr. Sumit Sen from IIT Bombay. So these are very interesting topics to sort of understand a little bit more deeper into when you're talking about today's session itself. And then a very specific event that we have at INGAS is the co-located ESA workshop. ESA is the European Space Agency. So we have folks coming from ESA to sort of join us at the conference, and they have their own talks mostly about synthetic aperture radar and its applications, and a lot of very technical workshop on that. So if you're interested to attend all of that, do register. But just to talk about how we have gone so far, we have almost 200 registrations for folks coming in person, and more than 300 research submissions of papers and posters together. That means if you are a student or you are an industry folk or you are a professional, you can register, come to the conference and talk to folks who have published these papers. It could line with your work that you're trying to do. They would have poster presentations in a big hall. You'll be able to see what sort of work they're doing. You'll be able to engage with them more personally compared to, let's say, LinkedIn or emails and things like that. So the idea here is that for you to sort of network a little bit more deeper into research in geoscience and remote sensing, but also across industries to see what these industry folks are doing in their companies, right? So a lot of their proprietary products will also be part of, let's say, the exhibition area. So there's a large exhibition area where all the sponsors and industry folks will be out there exhibiting their products, their research items and all of that. So you'll be able to walk into these stalls, talk to them, network with them, and see where these things can go forward. So it's an excellent opportunity to have this in person in India. And of course, all of these are available on our website. You can regularly visit them at ingars.org, where all of our updates are coming through on social media as well. Specifically, we also have a women in engineering and diversity, let's say, a group where we're trying to include more, let's say, spectrum of diversity for folks within geoscience and remote sensing. So there are a lot of these events that are a little bit focused on that, and we have a lot of speakers coming in to talk about their perspectives on, let's say, how women in engineering and what are the difficulties that they face. And we'll be talking to a lot of folks who are a little bit outstanding in those domains. And then also a lot of, let's say, young professional events. So the four of us here, the organizers, Aman, Santosh, Kuni, and a few other folks are part of the young professionals category in IEEE GRSS. Basically, we'll have two events that are out there. One is the story maps event, where you can actually do that right now as well. You can register and publish your story map, something that you would like to visualize. There's a specific theme out there, but what sort of visualization that you would like to see a little bit more interactive as a story map, and there are prizes for that as well. And there's also a little bit of Earth at Risk image contest, which is the standard in IEEE GRSS events, where you can sort of create satellite or process and visualize satellite imagery which depicts some sort of a natural disaster or anything of that matter which shows Earth at risk. And the best image for that will also win a prize under the conference as well. So a lot of these events are happening, and next month, along with Let's Talk Spatial, we are going to organize a hackathon at Spatial, and that should come up in your feed sometime soon once the dates are confirmed and all of that. So do keep in the loop for that as well. But again, all of our sponsors are out here, so if you are ever looking for a little bit more connectivity and networking from these sponsors, they'll be out there. There may be possibilities for hiring and all of that as well, so keep your eyes open. That's true. And then, as we said, this is in sponsorship with the IIIT Bangalore, and IEEE GRSS is going to be our main organization, and our technology and knowledge partners are out there as well. Right, but yeah, so the website is ingars.org. I'll just quickly alt tab to that. So the website will have all the details. It'll keep getting updated as we get more information, but you can head on to ingars.org and registration on this link. You can register as and when possible. We had the early bird tickets, but that is not valid anymore. We had the deadlines passed some time back, but you can still register. If you would like some sort of specific information about anything that you have in mind, do reach out to us. If you'd like to come through your organization or your college or anything of that kind, so we'll be sending out a little bit more detailed emails to all of you, just so that we get a little bit more participation in the conference as well. But since this is an mostly in-person event, we'll be expecting you there, and highly recommend you to also show up and register as well. But yeah, I think that's basically what I wanted to talk about the conference. Is there any doubts about, if no one has heard about academic or conferences or anything of that kind, I'd be more than happy to take it up. But yeah, just wanted to put this out into your feeds. Yeah, that's it. Thanks.
Anybody's, you guys have Today's nobody has any quiz. So I think that's it. This is the end of our talk. Okay, thanks Amrut for explaining about it, and thanks everyone for coming, and thanks Aman and Santosh for the nice talks. And if you have any questions or any networking, you can have now. We have a chai and then samosa served. We can have it, and then that's it. And we'll have one group photo before he leaves. Thank you everyone for coming. And would like to thank Satyukt for hosting us, and then IEEE for IEEE JRS for sponsoring this event, and also being one of the part of organizing this event. Thanks everyone.
Thanks to people on YouTube as well.
Yeah, for being active, at least YouTubers, they ask some questions.